Okay, so let's start with the actual workshop. This workshop is a follow-up on Git, so we will see how Git works in other apps like MATLAB, R, and Visual Studio Code. And on the way, we will also get to know some advanced Git commands because those are implemented in the apps. So first we have a brief rollback to Git, just a quick reminder, what is the basic workflow in Git, which commands should you already know, and which commands are important for the basic workflow. Then we go to Git in MATLAB. So we first will look at it, how it is if you already have a project that is already version controlled by Git. And not use the MATLAB project tool, but then we will also see how to set up a MATLAB project and use Git. And on the way, we will also get to know the commands git revert, reset, and stash, and also what Git attributes are. Then after this, we will see how Git works in R, and we'll also see what the command git amend does. Then while we're in R, we will see how to write a paper with RMarkdown. And in the end, I will give a brief introduction to Visual Studio Code and of course also show how Git is implemented there. And we will take a look at the command git rebase. Okay, so here's the quick reminder about how the basic workflow with Git works. So if we want to use Git in our project, we first have to initialize it with the command git init. And if we then start working in this project folder, we will add changes from the working directory to the staging area. We will commit them to our Git repository. And if we have a remote repository synchronized with that project, we will then push them to this remote repository. At any time, we can check the status of our project. And if we made some changes, we can inspect those changes by doing git diff. We can do that between versions in the staging area and in the working directory, or between already committed versions and the working directory. We can get updates from the remote repository by doing git fetch. So these updates will then be in our local Git repository. Then we can inspect them if we want and merge them with our local version to have the local repo staging area and the workspace updated. And by doing git pull, we basically skip all these steps and directly pull the changes from the remote repository to the working directory. And if we start the other way around, so we first set up a remote repository and then want to have it locally, we can simply do a git clone and have everything that we have remotely also locally. So this was just a quick reminder what we already know. And now we will see how all of this works in MATLAB. And like I said, this is an example for you already have a project folder, you already have Git initialized and did some commits. And you already also have a remote repository synchronized with that folder. Okay, so if you open your project folder in MATLAB and you already have Git initialized, then you will see on the right side of your files this Git column. And if you do a right click on your files and go to source control, you have all the functions that you can do in Git. And it's a bit more explained. So like I said, here on the right to your files, you have the Git status, basically. So the green circle means it's up to date. So your working directory looks exactly the same as the last version in your Git repository. If you have this blue square, then it means you modified something on your file, but you haven't added or committed it yet. And the black X means this file is not tracked by Git. With view and commit changes, you can do git add and commit. Fetch push pull is the basic git fetch push pull that we already know. With remote, you can add your remote repository by simply putting in the URL of your remote repository. With branches, you can create a new branch, you can check out two branches, you can merge branches, and you can also see your commit history here. Submodules is just another word for the code snippets that we also already got to know in GitLab. Stashes, I will explain in a minute. With show revisions, as you might assume, it's the git log, so you can view your version history. Also with compare to ancestor, that just simply means that it compares to the latest commit where your changes evolved from. With compare to revisions, you can do a git diff and revert using git. I will also show in a minute. So let's switch to MATLAB and just click around a bit that you get a feeling of how it actually looks like. So you can see MATLAB, right? Okay, cool. So here I already opened my project folder, and here I have just a basic analysis script that will do will produce some figures in the end, and I will just like make a change on this. So I will just give it another comment and write super nice analysis instead of super cool. And when I then go out of this file, here you see on the left, it automatically switched to this blue square to tell me here something is modified. Do you want to add and commit it? And here down, can you see my cursor? Mm-hmm. Okay, here it actually also shows me what I modified. So now if I do a right click on this file and go to source control, I can view and commit the changes. And now this window opens, and here you just get listed every modification you did. So I only did a modification on this one file, so only this one file is listed. But if I had done modifications on another file, it would be listed too. And by this check here, you can decide which changes you want to have in the commit you're going to do and which you don't. So if I had two files here, I can check one or both as I want it. So now I put my commit message here under comment. And then I will just commit it. Yeah, so now it changed back from the blue square to the green circle because everything's up to date. So now I already have a remote repository, but if I hadn't, I would have just go to your remote and just put the URL from your remote repository in that. You get that when you set it up, or when you click here on your remote repository to clone, just copy that and put it here, click validate and OK, and then it's set up. And when you've done this, yeah, you can synchronize it. So I've done a modification. I want to have it in my remote repository too. So I'm just doing a push. Done. It doesn't give me any complaints, so it should have worked. Let's see. Yeah, so here you can see that was my commit message changed comment. Okay, what else can we do? Yeah, so here with branches, when we open this, you can see here I already created some branches. And if I click here, I can see them all, also my remote branches. And by clicking on them and clicking on switch, I can just switch to that branch. And if I want to merge the branches, so currently I'm on the main branch and I just have to choose the branch I want to merge my main branch with. So if I want to merge it with that, I'm going to choose that one and then click merge. That's all. Yeah, that's everything to branches. Then we go here to show revisions. So here I have the complete commit history I've done so far. And when I click on this one, for example, I can compare to local. So that's my current version I have in my working directory. If I mark 2, I can compare selected. And then another window will open. And here you will have the comparison and see that the change I did from this version to this version is that I added this headline. Okay. That's the basics here. Does anyone have a question so far? Okay. So let's see what git revert is. So we saw earlier that we have this option, revert using git. So git revert basically brings back a previous version of your code as an additional commit. So this does not equal git checkout. Git checkout is there to move around with hat in your version history, and so you detach from your current branch and only go back to previous version to check it out. So this looks like here. So you've done 4 commits. Your branch tag is on the latest commit on your branch, and when you then do git checkout to the second version, hat will move with you to here. And you can just take a look at this version. If you wanted now to actually bring back this version, then you would have to create a new branch from this commit and then merge the new branch with the main branch. So that's one way to do it, but yeah, it's a bit complicated, or it's just unnecessary because we have the command git revert. So git revert adds, like I said, adds a previous version of your code as another new commit to your version history. So this looks like this. So if you wanted, so you've done 3 commits so far, and you want to have back the version from your second commit, you just do git revert, put the hash of the second commit, and then it will be added onto your already existing version history. So this way you brought back this version, but you preserved, all of your commit history. So in the terminal, it would look like this. You just type git revert -- no commit, and the commit hash that you from the commit you want to bring back. And this no commit basically just means that Git won't ask you for every commit in between if you want to preserve some of the changes. And in MATLAB, as we saw, you just have to do a right click on the file and press revert using Git. Okay, so let's see how this actually works. So I do a right click to source control and go to revert using Git. And so now I can just choose from my version history which version I want to bring back. So I say I find this headline better than the headline I added 2 minutes ago. So I just click on this version, click revert. And so now you saw it switched from super nice analysis to super cool analysis again. Now we also have the blue square again. So we have to commit it. And if we now look at our commit history, we see we have an additional commit saying revert to previous version, what I just wrote. And yeah, that's how you can bring back a previous version, which is useful, for example, when, I don't know, 2 commits ago, your code still worked, now it's broken. And yeah, you just want to go back to an earlier version. Okay, and here I just want to point out that git revert is not the same as git reset. So here on the top, you can see what we just, what I just said, the git revert to bring back a previous version. Git reset basically cuts your commit history at some point. So if you're on the 4th commit, for example, like here, and you do a git reset, it will just cut your commit history and go back to the 3rd commit. So that's 2 different things. So you should think about beforehand which of the 2 you want to have. There are 3 different modes of git reset. So if you do a git reset -- soft, this will only apply to your commit history, but your changes will still be in your staging area and your working directory. If you do a -- mix, this will also apply to your staging area. And if you use -- hard, it will apply to all of it. So your changes are definitely gone. And it's useful to know that by default, so if you don't add something after git reset, it will do a git reset -- mixed. Yeah, so this can be useful, but it's also super dangerous. So maybe start with a soft reset, inspect everything again, and only if you're sure you really don't need the changes you did, then do a hard reset, because every git command that has the flag -- hard is dangerous, just saying. Okay, and then there's a 3rd new git command, which is called git stash. So to stash means to store your changes, the changes you did safely in a hidden place, like the stash stack, just like squirrels do with their nuts. This is useful if you need to quickly switch to another branch while you're midway through some code changes on another branch and you don't want to commit it yet, but you still want to have it saved by Git somewhere. Sorry. So git stash takes your uncommitted changes, no matter if they're staged or unstaged, saves them away in the stash for later use. And then if you want, it reverts them from your working copy, and you can apply those changes then. You can do git stash pop. That means you apply the changes to your working directory, and they will be removed from your stash. But you can also still keep them in your stash if you want by choosing git stash apply. And if you do git stash show -p, it shows you the difference between the latest committed and the stashed version. This is of course useful when you stashed your changes, did some other work in between, and you come back to this work, I don't know, 1 or 2 days later, and you're not quite sure anymore what you actually changed. Okay, so let's see how this looks like. So if we, first we have to make a change. So we're just like putting away the headline. We don't need this. And then we go to source control and to stashes. So now here you can see that only the things we actually can stash appear. So we only made modifications on this one code file that we haven't committed yet, so we can only stash them. So I just click here on new stash, which means, yeah, I put it in the stash. When I close it now and click on my file, you see the headline appears again, because I stashed my changes and I didn't add or commit them. So they're just safe in a hidden place for later. Okay, so some time goes by, I come back to this work and actually want to apply the changes I made before. Then I go back to stashes. And I just click on this stash I made and I click pop. And close it again. And now when I click in my file, now I actually applied the changes I made before. And now I can commit it again. And have everything up to date. Okay, so that's git stash. Does anyone have any questions so far? Okay. Yeah, then earlier I said we will also look at this git attributes. So this is a file. It's a hidden file by Git, and it's there because sometimes Git can't figure out the actual underlying structure of a file. So sometimes Git doesn't know, is this file binary or non-binary? So usually Git is very good at that, but apparently it happens. Otherwise, they wouldn't have made this Git attributes. And if Git accidentally handles a binary file as a non-binary file, it might destroy your file, because then Git tries to do some operations on a file that just can't be done on a binary file. And to avoid this, you can just have this .git attributes file in your repository and specify the file type so that Git knows, please handle this file type at any time, please handle it as binary or as non-binary. Yeah, so there exists some templates for this that you can find, for example, on GitHub. For MATLAB, these specifications would look like this. So just put any file that can be created by MATLAB and is binary in this file with like the star and then your file format, and then put binary next to it. That's all. And here in this, there are also other common binary file types stated, like, for example, the docs, JPEG, PDF, and so on. And if you have this, then you're safe, and Git doesn't try to do things on your file that it shouldn't do. So if you set up a MATLAB project with Git, this file will actually be automatically created. So you don't have to take care of that anymore. And how to set up a MATLAB project with Git, we will see now. Okay, so I just have to switch folders. So here, it's actually the exact same project. The only difference is this one isn't version controlled yet. I will now set up a MATLAB project. You can do this by here, plus new, go to project, and yeah, you can create a blank project if you want. I want to create it from folder, but as you can see here, you can also create a project from a folder that is already under Git control. So I will click on from folder. And yeah, I can choose a project name. I will just leave it like that. And then, of course, my project folder is the folder I'm currently in. I want to have this one. And then it just creates yeah, this project folder, like a MATLAB project. And if I want to have this version controlled now, I just have to click on use source control. So now I click on add project to source control. Here I'm choosing Git. Project root is right. And then convert. Now it does a lot of things. And when I look at my project now, you can see here it automatically added the Git attributes file. And yeah, it looks exactly like the one I showed you on the slides. Yeah, so that's basically it. And now I can just, yeah, use the Git like I did before. And because I opened the project, I now have it here on the top too. So I don't have to like do right click anymore, but I can like use this. But yeah, it's basically the same. Okay. Does anyone have any questions to that? Okay. Okay, yeah, so I will share the slides afterwards with you. Here are just some resources you can check out if you have any troubles with using Git in MATLAB. Okay, so then we will switch to Git in R. It's a bit different to MATLAB because in R, you always have to set up an R project, no matter if your project folder is already version controlled with Git or not. So it doesn't, you can't use Git in R if you haven't set up an R project. So as you want, you can have Git initialized and also already added a remote repo before creating an R project, because you have to do this over the terminal anyway. That's also a difference to MATLAB. So in MATLAB, for every operation you want to do in Git, you have something to click on. But in R, some things you have to do over the terminal anyway. So you don't have a button for everything there. Okay, so let's first go into R and set up an R project. So I'm just opening the folder I want to have version controlled. So this is my R folder. And in the terminal, I'm already in this folder. So now I go here on the upper right corner to our project and say new project. And I will create it from an existing directory. If you choose version control, this means you will pull from a remote repository. So you don't have it locally yet, but only get it from a remote repo. So I choose this one. Then, of course, I need to go into the folder, open this one, and create project. Okay, so now it added some files. So for example, it added a git ignore file. And here you see it put in also this new tab for Git. And now you have Git in RStudio, and you have some buttons for doing some Git operations. So you can do Git diff, of course, commit, pull, push. You can see your version history. You can create a new branch, switch between branches. You can stage your changes. And you also have the option to revert. And yeah, with Git status, you also have like this different symbols and colors to see in what stage your files are. So I will just open my code, and I will just, I don't know, make a modification. And save it. And then it will appear here, and with the M telling me I modified this file. So now I'm just going to add and commit it. So here you can see with this checking, I can decide again which things I want to have in the commit and which not. And so I stage them now, then I do a commit. And if I click on the file, I can actually already see the changes I made, put a commit message, and commit. Done. And then, of course, here with changes, I can see my commit history. And now I already have a remote repository. Like I said, I'm just pushing my changes to the remote repository. So as you already saw, there's also this revert option in RStudio, but it's not the same as the revert command in Git or how you can use it in MATLAB. I mean, it's still Git revert. You can just not use it all the time. So like the revert command in Git can be used at any time. So you can use Git revert when you already committed changes. In RStudio, that's not the case. So you can only use the revert button if you saved your changes locally or already added them, but haven't committed or pushed them yet. So this revert option doesn't exist for any commit in your commit history, but only to changes which are not committed yet. If you wanted to do that, then you have to use the terminal. So that's one example for things that are not possible with the buttons in RStudio, but you have to use the terminal. So I'm just going to show you this. So if I click on history here, I have this revert button, but I can't apply it to any of my commits here. I could only apply it to the changes that are not committed yet. So let's do another change. So now I could revert it. Changes, blah, including stage changes. Are you sure you want to continue? Yes. And so now I reverted it, but I cannot do it here. I don't have a revert option here. Okay. That's all. But in R, you also have, of course, different commit options. So here you can also choose to which branch you commit to. Here, like I already said, you can choose which changes are going into the commit and which not. And there's another field saying amend previous commit. That's a new Git command that we haven't seen yet. So git amend just means that if you forgot something in a previous commit to put in, then you can just make the changes and amend those changes to the previous commit so that you don't make a new commit message for something you forgot, but just put it together to the last commit. So if you have this case, so here you can see it. So they did a commit and then they forgot to add this line to the commit. Then they're just making the change, go to stage commit and click this and then commit. And then it gets applied to the previous commit. So we can see how this is done. So I'm just doing some more changes. And now I go on to commit. And then I click on amend previous commit. What's wrong? I have some issue with my remote repository, apparently. I don't know why it doesn't work. I'm sorry. There's something wrong with my remote repository. Yeah, anyway. If you do this git commit amend, you have two different options. So when nothing is staged, so you don't want to commit new changes, but only want to change the most recent commit message, you can do git commit amend -m and then put an updated commit message. So that's for when you forgot to put something in your commit message only, not in what you're committing, but the message only. And when you stage a change and commit this one with git amend, then of course the version will change. And if you put no edit, then you don't change the initial commit message, but you can of course also use the upper one together with your stage change. Is that clear? Okay. Okay, so that's basically it. Like I said, there aren't that many options in R many different options, and at some points, so for some Git commands, you just have to use the terminal. Okay, so actually, I will go further with how to write a paper with RMarkdown, because that's about 15 minutes, and then we can just have like a 5 or 10 minutes break, if that's okay. Okay. So yeah, why am I showing you this? Our Markdown files can be version controlled by Git. So like I said multiple times, Git is not good at handling binary files. You can still track binary files with Git and push and pull them to remote repositories and save the different versions, but you can't do things like git diff or git merge with it. RMarkdown, like the application R, is an open source app, so anyone can download it. Nobody has to pay. There's no restrictions. It's not like with MATLAB, for example. So if you use the file format RMarkdown, anyone can open it. And if you use R for your analyses, then you can put the code in your Markdown file and having it rendered directly in the file. So using R Markdown for like writing your paper or your thesis when you work with R anyway is super convenient. And also this way your paper will just be reproducible super easily if you share the data and the code with it. So anyone can just click on go and have your paper rendered with all your code in it. You can not only write a paper with it, but you can also do presentations with it if you want. So an R Markdown file for writing a paper has basically 3 things you have to have in that file to actually get a proper output in the end. So first, it's the YAML header. That's basically the metadata about your document. So it's always surrounded by 3 minuses. Like when your metadata starts, it starts with 3 minuses, metadata, and ends with 3 minuses. And it has the metadata like your title, subtitle, then do you want to have a PDF document? What references are you putting in? What's your font size, line stretch, and so on. So that's basically how your design of your paper, let's say this. Then the second thing you need for an R Markdown file is your formatted text, of course. This formatted text follows the general Markdown language rules. So there's nothing specific to R Markdown, but it's just normal Markdown language. So for example, if you put like a hash, then it means it's a headline. If you put 2 hashes, it's a smaller headline, and so on. If you put like the stars around a word, it's going to be rendered as italic, 2 stars is bold, and so on. So it's actually, it takes some time to get used to it, but it comes with practice. And for a paper, of course, you also need citations. You don't want to put in everything by hand. And for this, you need 2 additional files, 1 file to state which citation style you want to have. So for example, APA, and 1 file that actually contains the information about your citations. And to put the citations in the text, you just make an add, and then it will appear here. If you put it without the square brackets, it will be shown differently than in square brackets, but that's, again, the Markdown language rules. Okay, and then the third thing are the code chunks. this is to include R code in your RMarkdown file, and it always has to be placed like this. So you first have to have these 3 backslashes, and then the rules and arguments about your code. So for example, here R only means yes, it's R code. That's the name I gave the code chunk, and this is an output argument, which means I don't want to have it displayed in the end in my file. Then there comes my actual code, and then 3 slashes in the other direction again. So this is, for example, if you want to put in or make a table out of your data, make a figure out of your data. This is how you put it in. And this way you can also choose, do you want to have your code and figure shown, only the figure, only the code, whatever. And then another really cool thing, you see, I work with R. Another cool thing about this is that you can also have the inline code, which means that you can put simple characteristics of your data, like variable names or the mean of the age of your sample. For example, you can put it in the running text. So for example, it could look like this. You just put your formatted text, and for variable names, you put like a code here with surrounded by 1 backslash. Can you still hear me? It says my internet isn't good. Okay. Or here, for example, where measured from, it just means this is my data file. So it will be rendered as this. So it will be rendered as variable names are these, because these are the variable names in this data file. And it says we're measured from 150 iris plants, because my data file has 150 rows. And the mean is, and then I just put the code for calculating the mean. So, and the cool thing is that, of course, these numbers will just update automatically as soon as you change something on your data. So if you give your variable other names, they, of course, will then appear here automatically too. Yeah, so that's it. I just want to show you how this looks in the end. So here is the template I created and which I will share with you afterwards. So here you see title, subtitle, the authors. I want to have a PDF document. I'm using APA as my citation style. And my references are stored in this file. So let's look at this file. So here you can see, here are all my references. This is the way you get references when you click on export as bib. Then it looks like this. And then you can just put it together in a bib file, or you can also have multiple bib files and just put them here. This APA CSL file I downloaded from Zotero. I can show you this. So here it's a style repository, so it has all common citation styles here. And if I just search for APA, I can find here that's the most recent one. Click on it and download the CSL file. I put it in my folder with my RMarkdown file and reference it here. Yeah. So just let's create a PDF file from that. So then it looks like this. It's the best paper ever. Can you see that? Is that big enough? Okay. So yeah, by my title and subtitle and how I stated the authors, it's displayed like this. Then I also have the list of contents. I told R I want to have this first after my my front page. I want to have the contents table listed. Also, I told him earlier here that I want to have automatic numbering here. Number sections, yes. So it just numbered my sections automatically. I didn't have to do anything for that. Then I also have the list of figures and list of tables. I also stated it that I want to have them included automatically with the headings I give them. Yeah, and I can also jump to them just like this. So this table, there's something wrong in my data, but that doesn't concern us. So the table I stated like this. I just put in, I read my table, stated it as a data frame, and then wanted it to render my table and give it the caption example sample. And because I have this automatic numbering, I have it here. I didn't do that. Then I can also put in figures that are not part of my R code. So I created this figure in another program, and then I just used the common Markdown language for putting in figures, give it a caption, and then it will be shown as this. Or I can create a figure directly here in R with this code chunk, which is shown here. And yeah, so here you can see the citations. They are in the APA style, and it also put automatically the references section. Yeah, so that's pretty cool, I find. Okay, so here are some resources on that. Does anyone have any questions? Yes, so I don't know LaTeX, so I can't really give an answer to that question. So in the chat, there's the question if RMarkdown is similar to LaTeX. The rendering looks the same, I find, but I never used LaTeX, so I don't know. I was told it's a bit easier than LaTeX, but I can't, yeah, give any personal, opinion, like personal experience on that. But Lisa said it's a simplified HTML. And yes, you can change the resolution of the images on it. That's what I stated in the first code chunk, like how big my figures should be, the one that I render directly in the file, and which resolution it should have. So there's a lot possible. You can also like lose yourself in it, and yeah, it's just like if you're not used to markdowns, it takes some time to get used to it, but it's worth it, I promise. Okay, so I think we can like have a break, maybe 10 minutes, meet again at 4:10 so that everyone can, I don't know, go to the restroom, get a coffee, and then we just will look at Visual Studio Code. This will take maybe additional 30 minutes or something, and then we're actually already done. Okay, see you. Okay, so the last part is like a very brief introduction to Visual Studio Code, just like the basic things, and of course how you can use Git and synchronize it with GitLab and Visual Studio Code. So to say it, Visual Studio Code is from Microsoft. There's also like an equivalent called VS Codium. It's in principle, it's exactly the same. It looks the same. It has the same feature. The thing is, just like the difference is, Microsoft will store some information about the work you're doing in VS Code. Like the metadata. So for example, how often in this month you used it or something, or for how long. But VS Codium won't do that. So it's your decision what you want to use, just as an information. Okay. Visual Studio Code is an in-between of a text editor and an IDE. IDE means Integrated Development Environment, which means it's code editors that include other things like compiler setup, debuggers, and other code analysis tools. And Visual Studio Code is kind of an in-between. So it's not a full IDE, but it's more than text editor. Its core features are AMAT abbreviations, so that you can state a code in a shorter way than it's actually done, and it will just automatically render it correctly for you. It has this IntelliSense, which basically just means it will auto fill when you start typing some sort of code, it will just do an autofill. Then it also has a terminal. It has, of course, the Git integration and a debugger. These first two things are only by default integrated for languages HTML, CSS, JS, and TS. If you want to have it for others, for example, for Python or for R, you need to install extensions. But luckily, VS Code has like a ton of it. So there is an extension for everything, and also for some things, there are multiple extensions doing the same thing. So and everyone can contribute to extensions. So if you want, you can also build your own extension and submit it to VS Code, and other people can download it and use it. So if you open VS Code, we will just quickly do that. If you open it, it will look like this. And the main thing you will see first is this sidebar, which when you open VS Code for the first time and don't have installed any extensions yet, will look like this. So you have your Explorer, where you just can switch between folders. You have your search bar. The Git integration is also already there. You have your debugger, and you have here your market for getting all the extensions. And you can move the icons around. And of course, if you get new extensions, you can also place them on the sidebar, and that's how you can customize it. So for example, I also have the GitLab integration and the Jupyter integration. So these are displayed on my navigation bar here too. And if I want to have it on another place, I can just pull it there. So now we're going to open like one project. So I will just click on my Explorer, and I will open a folder. So let's see. I will open this one. And here in this folder, I have a Python file and an R file. And so Visual Studio Code noticed that I have an R file here. So it also opened and displayed me the R extension that I already installed. And if I click on the file, it will just show me my Python file in Visual Studio Code with this IntelliSense. So the code is written and shown as it would be in Python. So the highlighting, for example, works there because Visual Studio Code knows that this is a Python file, and in Python it's done like that. The same is true for my R file. So if I double click on another file, it comes next to a file that I already have open. So here it's also has the code highlighting. And it also, when you create a new file and put a .py, then you get this cute icons from Python and from R here. So yeah, it just automatically notices that this is this kind of language. Yeah. That's it to the files we have. Then, like I said, we also have the terminal integration. So you have it here. If you don't already see it, maybe it's hidden here, then you can just pull it out, or you can also click on here, then it will open too. And with the terminal, it automatically navigates in the project folder you currently have open. And you also can open multiple terminals. So if I go on terminal, it just has the standard terminal that I would have if I just open it here on my Mac. But I can also get other terminals additional to it. For example, I could also get an R terminal. That's just activating the extensions. Okay, now it doesn't do anything. Wow. Anyway, it should give me my R terminal here. I don't know what's happening. And if I click on this, I can have both of them next to each other displayed, or I could also split the terminal and have it one on the upper half and one on the lower half, and so on. Yeah, so that's the terminal, and like I said, usually you can add terminals, for example, an additional R terminal or MATLAB terminal too. Then another thing which you will use often when you use Visual Studio Code is the command palette, which lets you search for any kind of information and navigate you to any menu that exists in Visual Studio Code. So that's just an easier way. Instead of clicking through everything here, you can use the command palette and search for what you're looking for. So it opens here, for example. So I'm searching like for my settings. So this is also an important thing in Visual Studio Code. Behind everything, you have the settings.json file where you can put important settings for example, your extensions. So like you see here, I have a MATLAB extensions, I have the R extension, and for example, I stated here where Visual Studio Code can find the actual R or MATLAB app that is installed of my computer. because it needs that, the extension needs to know where to find this. But also other things like files autosave after delay and stuff. So that's actually something important. Like every time when you install an extension, you should go on the settings of these extensions to make sure that everything, that the settings are right, because if you don't do that, then you get unnecessary problems like can't find path or whatever. So just every time you install an extension, first take a look at the settings, what you have to define and what not. And then this settings file will also automatically update. So for example, if I just go in my user settings, and now I have the autosave on after delay, and if I just switch that, then my setting file will also update. But if you wanted to, you could also just change it here. Okay, so that's something important. Like every time you get some sort of error message from VS Code, just first take a look at the settings of your extensions. Most of the time, it can be solved by that. Okay, so now we're looking at the Git integration. So here, my folder, my files are already version controlled by Git. So that's why I see this folder here. That's the folder name. And now if I, do make a change here. So for example, I want to have this written this way. And then I save it. Then it should show me the file. Oh, why doesn't it work? Visual Studio Code doesn't like me. I don't know. I think my Visual Studio Code has some problems with updating, because it says me I modified it and I have Git here, but I can't click here. And here you see like this clock tells me that something is modified, but I can't click on it. I don't know what's happening. It says changes 0.
Change comments.
Sorry?
Don't you have to enter a comment? So.
Oh, you're right. I'm sorry. What? No, because it's supposed to show me the file that I modified. Yeah, I don't know. I'm sorry. This doesn't work, but in principle, you should see the file that was modified, and then you can, just commit it, the changes, and do like the standard operations with it. So pull, push, clone, and so on. And you can also add a remote repository. Here again, you have stash. What you also have is something called rebase. So that's something we haven't seen before in the other Git integrations. So git rebase, that's a new advanced Git command. It solves the same problem as git merge. So it integrates changes from one branch into another branch. So if you use git rebase, it's the same as with git merge. You always speak of two branches when you do that. It just does it in a different way. So it solves the same problem, but in a different way. So here, that's our case. We have two branches, the feature and the main branch, and we want to somehow integrate the changes that were made on the main branch and on the feature branch from the point on when it diverged. If you do a git merge, then you will just take these changes, like this commit and this commit, and put it together and create a new so-called merge commit. So you will have here an additional commit where this commit and this commit get integrated. With git rebase, you rebase the feature branch onto the main branch. So when you look at this again, Git just pretends as if your 3 commits on the feature base were evolved from here. So you started making the new branch here, but then the rebase does it in a way that it integrates the changes from main in a way that it just puts the feature branch on top of it. So this sounds nice. And of course, it gives you a much cleaner and also a linear project history. As we already discussed in the introductory workshop, if you work a lot with branches and you merge a lot, then maybe your version history will get contaminated with a lot of merge commits. But this merge commits also they contain useful information, because sometimes it's really useful to know when someone integrated the changes from someone else and how the state of the project was when this person merged. So that's the one thing. And also this is again a bit of a dangerous command, because if you do it the other way around, so in the first example, we merge the feature branch onto the main branch. If you don't pay attention and you make it the other way around, so you merge the main branch onto the feature branch, you completely destroy the main branch someone else is working on, because you integrated you made your commit history the ancestor of the main branch everyone else is working on. So everyone else will just get a lot of merge conflicts. So yeah, you just have to be, again, careful with this one, but there's also some cases where you have valid reasons to do that, just so that you know what it is, because you can do it in Visual Studio Code with one click. Okay, and then of course you can also add a remote repository, but by default Visual Studio Code asks you to synchronize your work in Git with a GitHub account. So if you want to see if this works, add a remote. I'll do this. I'm sorry, it doesn't react. Anyway, if you click on add remote, then it should open. it should open something that says, please enter the URL of your GitHub account. So by default, you cannot synchronize it with a GitLab account if you do it through Visual Studio Code. So for this, you need to install a GitLab extension, and then it works. So the extension I installed is called GitLab Workflow. So you can just go here on extensions and search for GitLab Workflow. It's this one. And then you have to click on install. I already installed it. And here you could see the settings. That's what I was talking about before. That you should go through here if you need to set any paths or something for the extension to work. And if you installed this, then it will appear here in your navigation sidebar. And yeah, I'm sorry, it's stuck somehow. I don't know. It doesn't get any connection to the internet. Anyway, if it would work, the project you have, now it reacts. Yeah, that's because I clicked so often. All right, maybe now it works. I think it did what I wanted it to do. So yeah, now it works because here you can see the project appear if it is version controlled by Git. So if you do a right click on that, then you can just say manually assign GitLab project. And then put in the URL from your GitLab project. For this you have to create a personal access token. So if you go on your GitLab project, so this is this one, or you go on your account, you can create here access tokens. So you just give it a name. For example, I gave mine the name VS Code. I put in, yes, I grant complete read and write access to this API, and created it, copied it, and placed it here in Visual Studio Code when I was asked to. And this way I can just synchronize the work I do with GitLab. And some other cool thing, if you did that, is that you could actually tell Visual Studio Code to just every once in a while run git fetch, so you don't have to think of it yourself. So that can be something super useful. Yeah. So yes, I wanted to show it to you, but I don't know, it has some synchronization issues. I don't know what's going on. But yeah, here you can see what appears when you here click on add remote. Then this field will appear with the GitHub, and this will only appear if you have the GitLab extension. Yeah, so that's actually it for today. I hope you learned at least something new and it wasn't too boring, but yeah, I mean, it's not a very exciting topic. Does anyone have any other questions? No? Okay.